Hey, I am just here looking like I work at a call center to show you something that was missed from 8.3. And this camera is weird, so I'm going to turn it off because my computer is like right here, but then the camera's over here. So I'm going to turn it off and share my screen. Okay, oops, let me just shrink all this unnecessary stuff. Cancel. Okay. So one thing that was missed from 8.3 were these problems right here where it's asking you to find the t-score or the degrees of freedom. So for starters, I just want to remind everyone this was mentioned in class briefly, but we didn't talk about it very much. Degrees of freedom is n minus 1. So for this problem, there's 10. So this is suppose the individual times it takes for a running team to run a mile is normally distributed with the unknown mean and standard deviation. The times of 10 runners, so n is 10, are used to estimate the mean time of the team. Use the calculator to find the z-score for a 95% confidence interval. So for this problem, the degrees of freedom is 10 minus 1, which equals 9. So the degrees of freedom is 9. Now, for the calculator, when it doesn't give you this extra stuff and we're just trying to estimate the mean time of the team or estimate the mean time of something, we're going to go over here to our inference, our confidence intervals, our means. We're getting the t-score, so go to t-interval, input statistics. And what we want to do here for the mean, I'll write this down here. Mean, use, I like this little arrow, use 0. So I will type in 0 for the mean. This is just a special scenario when you're only given n and you're not given the mean standard deviation. And we don't have population sample anything. We're just estimating the mean of time of the team. For standard deviation, or S, we are going to do, oopsies, I like my little arrow. We're going to use the square root of n. So over here at S, I know my n is 10, so I'm going to type in square root 10. And then again, n is 10, confidence interval is 95, and there's my t-score. It does give you the degrees of freedom also, but that one's just a quick do it in your head because some of the problems just ask for that. Okay, we'll do this one more time. I'll copy this information down below. Ooh, not all of it. Okay, come on. So here we have one more problem. I do not like this computer. Okay. Suppose that the test scores are normally distributed, unknown mean, unknown standard deviation. So we're using T. The scores of 20 students are used to estimate the mean score. And we're doing a 90% confidence interval. So 20 students means we have the degrees of freedom of 20 minus 1, which is 19. For the mean, we're going to use 0. And for the standard deviation, we're going to use the square root of n. Now this is, I should have written this out last time. This is where people get messed up because they have 19 in their brain, so they want to use 19. But remember, n is actually 20, so we want to use 20 right here. So I'm going to go back. I'm just going to go back to the beginning just to remind you where we came from. We are at inference, intervals, mean, t, input. Our mean is 0. Our standard deviation is going to be the square root of n or the square root of 20. And then n is 20. And we want a 90% confidence interval. I'll write out the answer this time. Okay, so for this one, the answer would be, oh, come on, I don't need to be that far away. T equals lowercase t. And it says to round to 3 decimal places, so I'll go 1.729. Ta-da! All right, if you have any questions, just talk to me in class on Friday or send me an email. Oh my gosh, I'm messing everything up. So I'm going to go send me an email or talk to me in class on Friday.